On video.
Alright, so definition of the derivative. So this is under the lines of the, and you don't necessarily need to write these down, you can just sort of follow along. I can give you these pictures if you need them really. So remember I said there's two problems dealing with calculus. One is the slope of the tangent line, and so what we're trying to do is we're trying to find the slope of this function right here, x equal 1. Okay, here's my function, is this one right here. So what we do is we start with the slope of the secant line, and that gives us an approximate. So we pick a couple points on the secant line, which is the one that just connects two lines, passes through the bottom twice. And we can, figure out what the slope of this line is, right? Would it be the same as the slope of this line right here? Probably not so much, okay? So let's just get a little formal with the definition of the slope of the secant line. So we've got our little point, we've got our other point. Now, the distance between the 2 points is delta x, and they're delta x apart. So that's that change in x thing that we've been dealing with. Sneakily, we snuck that into the problem because it becomes important. Okay? So this distance, my run, if you will, of the slope of this line is delta x. My rise is the difference between these two coordinates. So the top coordinate is the f of x plus delta x. The bottom coordinate is just the f of x. Okay? To find the slope of the secant line, I just do the rise over the run. With me? Okay, so that's going to tell me the slope of this line. It's not the slope we're looking for. We're looking for the slope of the line down here. All right. So what we do, slower motion, is we keep moving that point closer and closer together. Delta x becomes a little smaller. Now the difference between the f of x plus delta x and the f of x becomes smaller as well. The slope of the secant line, my new darker secant line, is still the same formula. The rise over the run, or if you like, change in y over the change in x, right? Same thing we've been doing. Okay? So we're still not quite there. It's a little closer. The slope of this line looks a little closer than the slope of that line. So we move forward. And we keep making delta x smaller and smaller, and consequently the difference between the difference in my y values gets smaller. So we're using that same thing to do it, change y over change in x, rise over run. Okay? So what our plan is just to keep making this delta x smaller and smaller and smaller, which would make this quantity right here smaller and smaller and smaller. And so ultimately we get to a place where the secant line starts to look like a tangent line. See, as I'm here, these distances are pretty small. Yeah, remember that green line that I drew in there originally, about there-ish? My slope's getting closer and closer to that line. Does that make sense? Okay? So what we really want to do is we want to get to the place where this change in x is essentially 0. Okay, and if the change in x is 0, then on the bottom I have 0. This is 0, I have the f of x minus the f of x, so I have 0, right? And we know what happens when we have 0 over 0. More work to do. Okay? So what we end up doing to get the slope of the tangent line is we just take the limit of the slope of the secant line. So this information right here, the slope of the secant line, the f of x plus delta x minus the f of x over delta x, that, when we take the limit of it as delta x goes to 0, that becomes the slope of the tangent line. Okay? And that's a formula we're going to get used to seeing, because we'll see it a lot in the next couple of days. All right? So we're going to try that. We're going to try to find the slope of the tangent line of this function. Here's where you probably want to start. So in order to find the slope of the tangent line of this function, we're going to use the formula. And we can use that same thing we just did, the limit of the f of x plus delta x minus the f of x all over delta x. Okay? Remember what it means to find the f of something? If I asked you to find the f of 3, what would you do? Put 3 in for x. So 3 times 3 is 9, plus 4 is 13. So this particular formula is asking you to find the f of x plus delta x. So what are you going to do? Put x plus delta x in wherever x was. So to rewrite this, is it okay if I use green, or is it better color?
That's fine.
Is that all right? So the f of x plus delta x is 3 times x plus delta x took x plus delta x, put it right there where x is. Okay? And then we're going to subtract the f of x, which is this thing. And I would suggest put the parentheses, so that way we don't lose any signs. Okay, so we've got the f of x plus delta x, subtract the f of x, all of that, so over delta x.
How can we subtract 4?
Say it again?
How can we subtract 4?
Because I made a mistake, thank you. That was Olivia making that correction. Watching it all. Yeah. Thank you. Good? So, I mentally got a step ahead of myself, I think is what happened. So this sort of hopefully looks like a problem you've seen before. We had a problem something like that on the test, I think. So what do we do? We distribute it, so we're going to do 3x plus 3 delta x plus 4. Still doing the limit as delta x approaches. Minus 3x minus 4. All over delta x. Agree? Okay. So then that allows me to do some things to simplify that function. 3x minus 3x, that's 0. So that's good. Plus 4 minus 4, that's 0. That's good. So then this becomes the limit. Delta x approaches 0. 3 delta x over delta x. What can we do with that?
Cancel out the delta.
We can cancel out delta. Delta x over delta x is 1. So now we're asked for the limit. Delta x approaches 0 of 3. So what's the limit of delta x approaches 0 of 3? 3. Okay? So that's the slope of the tangent. So if I were just to ask you originally, what's the slope of 3x plus 4? You said 3. All right. What's the slope of y 3x plus 4? 3. So we found the slope of the tangent line, and this is the linear function, right? So if I have a linear function, how do I make a tangent line to it? You don't really, so it's the same. This turns out to be the same basic line. Okay, anywhere along the slope is the slope is the slope. Yes, ma'am.
Why did we use that to find the slope if the slope is right there?
The reason we did this problem the way we did it is I wanted to have us work through a problem using this formula and come up with an answer that we could then verify that made sense to us. So the fact that we got 3 by finding this this way verifies that we already knew the slope was 30, although at the time you didn't know that that's really the question. Okay, so it's just to show you that the process works. When we get to a little more complicated problems, when we get to part 2 of this display, we it won't be quite so much. Okay? So the slope of the tangent line is also known as the derivative. Okay? And we write the derivative in several different ways. So we write this with the f with a little apostrophe after it. We say that's called f prime. And it's this. The f of x limit is delta x equals 0, the f of x plus delta x minus the f of x all over delta x. This right here is the definition. And there's 9 right? Of derivative. Okay. Other notation that we use, dy dx, what you would say is the derivative of y with respect to x. We use y prime sometimes, and we use the derivative of the function d by dx of the function. Those all mean the same thing. They all mean that we're finding the derivative. They all mean that we're finding the slope of the tangent line. So when we talk about actually doing KVs and ask about the definition of the derivative, that's the definition of the derivative. The limit is delta x approaches 0, the f of x plus delta x minus the f of x, all over delta x. Okay? And this page is in your notes, which I know myself. This page is in your notes also. So we will use these 3 phrases interchangeably, and they all mean the same thing. We'll say the slope of the tangent line, that means the derivative we'll say the derivative, that means the instantaneous rate of change. Say the instantaneous rate of change, it means these other things. Okay? So anytime we see any of these three words, you think the other one. Okay, the derivative is the thing that you can easily, pretty easily find. If someone's asking us for the slope of the tangent line, they're asking us for the derivative. If someone's asking us for the instantaneous rate of change, they're asking for the derivative. Okay, they all mean the same thing. Right? That's about all I've got. Okay, the part two goes on to do that problem. And another problem afterwards. So we'll save that thing for later. Okay? How about mistakes? 10 minutes, 47 seconds.